In this video, I'll be showing you how to make a ratio level histogram. At the ratio level, we're going to take data and divide it up into equal intervals between the minimum and the maximum and count how many data values occur in that interval. Taking a look at this length of leaves measurement, these are leaflet lengths in centimeters on a particular plant known as Senna alata. Locally, it has some other names, but used to treat skin funguses. And you can see that the longest leaves are around 12 centimeters and the shortest are around 3 centimeters. There are a lot more leaves in the 12 centimeter end of things than 3, so we can expect this to be somewhat skewed. What we refer to in English as maybe being lopsided, but in statistics we call skewed. Now, I could tap an A1 and try to make a chart, but that won't actually work in this case because there are 2 columns of data. A histogram is not going to be an option. What I'll have to do in this case, whenever I've got columns of data next to each other, is select just the data column, then plus, then go to chart. It may well give me a line chart. That's not what I want. I want a histogram. There's 2 ways to get a histogram at this point. One is from here, tapping on that. The other, if that does not appear, would be to go to this icon here, which will also get me the same histogram. So either of those icons will get you the histogram. And in this case, it gets me the histogram that I expected. Very few leaves are in the small end. Most of the leaves are between 10.6 and 12.5 in length. At this point, I can go ahead and get rid of that leaflet length centimeters count legend. I don't really need the legend, so I'll tell it to go ahead and drop the legend. The titles, I do want a left axis title. That's the frequency. That's how many leaves there are in each of those categories. And the rest is set up pretty much the way I want it. So I'll simply click check, and there's my histogram. We'll learn in section 3.4 to call this a skewed histogram with the tail to the left. This is the tail about here, and so that's a skewed histogram, skewed left, because the tail is on the left. That sometimes doesn't make sense when you first learn statistics. You think, yes, but everything's on the right. All right, but it's the tail that determines how we characterize the skew, which is a more significant tail. And just to show you, I'll do the same thing for these marble masses, the marble mass data, and plus chart. Again, I'll get a line chart. Again, I can go over here. This time, just to show you, I can click here, and I get a what'll turn out to be bimodal and skewed histogram. This time it's actually labeled the x-axis, that's fine, but that's really the frequency, not the marble mass. So I would want to edit that from the edit menu, but you can do that. You go to the left vertical axis title, tap up here, and you can say frequency of marble masses, and update that title, check. And that's all there is to doing a histogram at this level. Now, if there's too few, the number of data elements are too few, you won't get a option to do a histogram because there's just too few data elements available to you. You go over here, you see that the histogram option has indeed disappeared while it's here, but it's meaningless at this point because there's too few. We can't control the number of bins. These are called bins, buckets in Google's parlance, intervals, or classes in statistics language. So they have many different names, but these numbers at the bottom, here in the app, we can't control them. They're called buckets by Google, and you can control them if you're on a laptop or desktop computer. In that interface, you do have the ability to control the size of the buckets. But for our purposes in Introduction to Statistics, these histograms are fine histograms. They're basically based on roughly the square root of the number of data elements. So here we've got about roughly 25 elements, 24. the square root is 5, 4 point something. It's rounded to 5, and so that's how Google has chosen the number. This number of columns in the histogram will change according to the size of the data. The more data you have, the larger your count, the larger the number of buckets running roughly as the square root of the sample size. But that's just a detail about how Google constructs these. And that's all there is to making a racial level histogram. It's the shape of the histogram that tells us important things about the data. Most importantly, whether the data is distributed in a nice symmetric heap, which we'll learn to call a normal distribution. So that's all there is to creating racial level histograms in the Google Sheets app, at least for a course at the very introductory level of statistics. In a more advanced class, you'd worry more about specifics of interval size and other issues. Thanks for watching.